Hello guys, so just about a week ago I built this craft here. It's a remotely controlled raft powered by old server fans, and I uploaded a short trailer video about that project just a couple of days ago. And in today's video I now just want to go a little bit into the details of the building process of that raft. Now please notice that this is not really a list of recommendations, but rather just a documentation of how I built this, because I both envisioned and implemented this idea within just a couple of days. So there is a lot here that can probably be optimized, but this worked out pretty well. So let me just show you what I did. And also there are a couple of lessons here that are, well, useful beyond this project. For example, learning about insulation material for objects that are supposed to swim on water, using fans, be it server fans or computer fans, to power an RC craft, and then repurposing the remote control electronics of old toys for a variety of projects. So let us start at the beginning and with the most basic component of this whole thing, and that is the insulation board itself. This is a material called Styrodur, which is a trade name of the German company BASF. And this is a special kind of extruded polystyrene, XPS, and it is typically used for insulating basement walls. Here in Germany, this kind of insulation is called Perimeterdämmung, which directly translated would be called perimeter insulation. And you can certainly use other kinds of insulation boards, but at least I can say that this material is much easier to work with and much more rugged than a more old-fashioned styrofoam, for example. And I first encountered this material a couple of years ago when I was experimenting on small-scale wind turbines. As you can see here, I cut the boards into pieces with an ordinary knife, and then I ground the surface off with sanding paper, much like I would do it with wood. And it delivered reasonable results, and maybe in some future episode I will talk about my wind turbine experiments. And to make it short, this is one of these things that never really saw the light of day because I just don't have the kind of open space, the kind of area in which you can just set up wind turbines and experiment with them. So even though this delivered some interesting results, it didn't really come close to an innovation that could be useful in your everyday life. But other than with the rudders, it was not necessary to craft this insulation board into any sophisticated form in order to have a proof of concept for this RC raft idea. So what I did is to simply cut an angle to what I defined would be the front side of the raft with an old-fashioned rig saw. And well, to be honest, you probably don't even need this angle. Next, I decided that I would mount the fans that would power the craft, as well as those for steering, and the electronics on separate wooden panels. And because I didn't have anything else, I used the MDF medium density fiber board from the back panel of this broken picture frame here, and I cut that into 3 different pieces with the help of my old jigsaw. But before I could mount the fans onto those wooden panels, I had to do some slight modifications here. And as you can see, there are several plastic parts attached around the actual fans, and that is because these units come from compact servers, and I guess this is some kind of quick release mechanism. You can also see that you have a 6-pin connector, and out of these 6 pins we only need 2, conveniently the black and the red one, for ground and plus 12 volts DC to get the fans running at full power. And later in this video we'll talk a little more about the electronics, and I will give you some hints what the other 4 pins are good for. But for now it was all about simply getting the fans running without spending extra money. So I simply cut the wires and soldered some other pieces of wire to them. And in the next step I first drilled a couple of holes through these angled bottom plastic parts of the fans, and then also a lot of holes through the MDF panels to then bolt the fans to the panels via M4 metric bolts. And then I used rather large wood screws that I had lying around in order to attach the panels to the board. Now it would be possible, of course, to use wood screws to screw the fans directly to the board, but there's actually only very little space at these angled plastic parts, so the M4 bolts would just fit through, while the large wooden screws with the larger heads wouldn't really fit. And another reason why I used the wooden panels is so that I could mount all electronic parts in groups onto these wooden panels and then could simply exchange this insulation board for another insulation board by just unscrewing a bunch of wood screws, because I didn't know if the board would turn out to be too large or too small or anything like that. Remember, this was still an experiment. And in the next step I drilled a couple of holes through this aluminium angle plate here, and pieces of that plate will hold a large lead acid battery in place. Next, a couple of holes were drilled through this ordinary plastic lunchbox here that will serve as the enclosure for our receiver and control electronics. And in order to fasten the lead acid battery onto one of the MDF panels, I used two daisy-chained zip ties. And using two zip ties in series when one is actually too short is really a no-brainer when you think about it. But believe it or not, the idea never occurred to me before I had watched Roadkill and learned this very trick from David Freiberger. So thank you a lot for that piece of advice, David. And in the next step, I took this old power cord here, salvaged from a vacuum cleaner, and removed the outer layer of insulation. After that, I then soldered pieces of that power cord to each and every one of the fans on our insulation board. And in terms of mechanical build and power electronics, the raft is just about ready, so we can now test if the fans are even working. But simply having this craft float on the water and having 6 heavy fans installed is of course not enough to control it. In order to realize remote control, there are of course a lot of options. You could simply buy a kit for that, or you could use Wi-Fi or other more modern solutions. What I'm going to do here though is to salvage something, and I will do that by taking apart this old toy car here, which can not only drive forward and backward and steer to the left and right, but also has a sound transmission capability. And normally there was a microphone attached to the remote control, which I replaced with RCA connectors, as you can see here a couple of years ago when I was playing around with that, and that is really not necessary for the RC raft build, but I'll show you more about that later in the video anyway. So what I basically did is to take apart the enclosure of the toy car and take out the 2 little circuit boards that we find inside. And as you can see here, I have attached a battery pack for 6 volts DC to this receiver circuit that I will use on the raft. You could use the 12 volt lead acid battery and a voltage regulator to obtain the 6 volts. But I have learned in the past that it is better to have an independent voltage source for the receiver circuit, because it can be very easily disturbed by noise coming from larger motors. For example, from the fans that we're going to switch over a couple of relays. And also another piece of advice here: if you take apart a toy car like this, take a picture of the bottom side of the circuit board before taking it all apart, because the wires are often only very loosely attached to the soldering joints on the bottom side, and in this way you can later find out at which point they were connected to the board. And because this might be a little confusing for some people, let's go over the different wires here and what they are good for. First of all, we have the red wire again for VCC, that's the supply voltage of +6 volts. Then we have the black wire for the common ground. Then the green and yellow wires, those are the connectors that go to the servo, that's a little motor with the gears used for steering. And then we have a brown and a blue wire, a bit thicker. and they led to the electric motor that powers the drive of the car. The other wires that remain now will not be important for anyone really watching this video, because the brown and blue one on the right side are for the loudspeaker, which most toy cars just don't have. And then there is a pair of red and a pair of black wires, and that is, I guess, for lights that used to be attached to the car. But when I bought this, these wires were already cut off, so I really can't tell. Well, but however, they can't be too important because we don't need them for any of the basic functions of this car. So we have seen that the receiver circuit actually works with the motors that came with the car. But of course, the fans on our raft are much larger loads. In fact, if you power 5 of them at one time, that would be 4 for the drive and then 1 for steering, you would be around 160 watts of load. So we're talking something around 13 or 14 amperes flowing from the battery to the entirety of the motors inside those fans. And of course, our circuit that was used before is not capable of switching these kinds of currents. And that is why I have to make an additional board that can be connected to this receiver. But before I go on, let us make a simple observation here that will explain how we can go on from this point. I have now disconnected the original servo and motor, giving us 4 cables, the green one, the yellow one, the thicker blue and brown one. And I am now attaching a multimeter to one of those 4 and the common ground, and then I give commands with the remote control and we measure at which point in time there is either 6 volts or 0 volts present at each of those 4 wires. And in this way, by trial and error, you can learn which of the 4 wires corresponds to the commands given by the remote control. For example, if the drive lever is pushed forward, the blue wire is pulled to 5.4 volts, the supply voltage of the circuit, which also could be interpreted as logic 1. If the lever flips back to the neutral position, it is pulled down to 0 volts again, or logic 0. The same is true when you push the lever back. The brown wire is pulled to the positive supply voltage, and it flips back to 0 in neutral or when the lever is pushed forward. The same can be said about the green and the yellow wire and the steer left and steer right commands on the remote control. So in conclusion, this means that even though the small H bridges on the original PCB are way too small to switch our fans, we can still use the voltages present at those 4 wires, that is between the wires and the common ground, as logic signals that can then be fed into the base of a bipolar transistor that can in turn be used to switch a relay designed to handle the kind of currents that will flow when all our fans are powered at the same time. Okay, so I think there is still a lot unclear here, so I have drawn a picture and let me show you what I'm talking about. What we have here is first our 6-volt battery pack and then our 12-volt lead-acid battery. And I marked the plus pole of these 2 voltage sources as VCC1 and VCC2. And if you take a look at the entire circuit diagram later on, please notice where VCC1 and VCC2 was applied. It can be important if you do not want to destroy a part of your circuitry. What we have inside the car, or from inside the car, is then a receiver circuit and also some circuitry that I'm just calling a decoder here, because there are impulses being sent and they are being decoded into some kind of switching signals. Then we have driver circuits. Now these can be just a couple of resistors, just a couple of transistors, or actual integrated driver circuits. That depends on what kind of receiver circuit is lying in front of you. And since there are basically thousands of different RC toy cars, there will also be a large number of different circuits. So these are just abstract representations. And in this particular circuit and in many others, we will then find at least 2 H bridges for the 2 different motors that we have, and an H bridge, also called a full bridge, is nothing but a bridge made of 4 transistors, in this case 4 NPN type bipolar transistors, and they are rated for rather low currents, something around 500 milliamperes at maybe 20 or 30 volts between collector and emitter maximum voltage. The bases of these transistors are connected to the driver circuits, and what these driver circuits do is to supply a sufficient current in order to switch the transistors and also to not allow a short circuit, and that means that only Q1 and Q4 or Q2 and Q3 can be switched on at the same time. Otherwise, these transistors would create a direct short between VCC1 and the ground. So the driver circuit has to be designed that way that that is forbidden. Now, a motor is connected between the 2 points in the middle of this H bridge, and the voltage arrow in front shows us that at this point in time, for example, Q2 and Q3 would be turned on while Q1 and Q4 would be turned off. And when that is reversed, so that Q1 and Q4 are conductive and Q2 and Q3 are not conductive, the voltage arrow across the brushed DC motor in these cars is turned around, and thus also the sense of their rotational direction. Now, please notice that the motors inside the server fans, as well as any other computer type fan that I have ever seen, is basically a brushless DC motor and not a brushed DC motor. The sense of direction cannot be reversed by exchanging the plus pole and the ground pin. You might even destroy the motor by doing that, so please don't try that. Here you can have a look inside and see that there is a lot going on in these motors, and I actually reverse engineered one of these some time ago. Maybe we will talk about that at some point in the future. If you want to know more about the difference between brushed and brushless DC motors, watch my video about the topic, which you can find in the video description. Now, however, we have already discussed that the currents that these H bridges can deliver is too low in order to switch our fans directly. And one way to circumvent this problem is to introduce a relay or relays instead of a motor. And you can see here that you only see 2 inductors. Those are supposed to be the coils of 2 different relays. That's why it says RE1 and RE2. So I have left the switches out in this drawing. And you can see 2 diodes, each of them in series with one of the coils, but in anti-parallel direction. And if you have such a circuit where the motor was, then you can actually use that to switch either relay 1 or relay 2 depending on the states of the 4 transistors. I have done that before. The problem is that VCC1 is only 6 volts, yet all relays that I happen to have are for 12 volts. And that is why we cannot use this very simple topology this time. But what I will do is to build up another circuit that is built up of a BD139 bipolar NPN transistor, and it has a 1 kilo ohm current limiting resistor switched in front of its base just to protect the transistor, and then the emitter is just pulled down to the ground. And at the collector branch we have the coil of a relay and a 1N4008. That is just a universal type silicon diode that is to be connected in parallel to the coil of the relay in order to catch the flyback energy that is released when the relay is switched off, and otherwise that energy that is stored in the magnetic field of the relay could harm or destroy our switching transistor. Then you can see that the switch of the relay itself is connected to VCC2, so 12 volts, and the plus pole of our fan, while the minus pole or ground pin of the fan is just connected to common ground. In that way, you can now switch very heavy loads, depending on the size of the relay, via this control circuit. And the circuit board that I'm going to build will simply contain 4 of those identical circuits, and one of them will switch 4 parallel fans, 2 of them will switch the 2 fans for steering, and one will be completely useless at this moment until I'm thinking about something else that I want to use here. And one more sentence about this: if you don't like this whole RC car salvage thing, you could also use this simple transistor relay circuit in conjunction with an Arduino. So in the next step I implemented this circuit by taking a piece of Vero board, aka Perf board, in German Lochrasterplatine, and I resized it and drilled a few holes in it so that I could mount it onto the insulation board later on. I then soldered all the components that you could see in the circuit diagram onto the board, and I connected the board to the 4 wires that we measured before. And here you can see that the relays are now being switched when the remote control is giving the corresponding commands. And in the next step I simply connected everything together and tested it again. But then I took the time to put it all inside this blue lunchbox and also, you know, order the wires a little bit, pull them together with zip ties and so on. And I also equipped the circuit with one of these, well, rather cheap antennas that came with one of the RC toy cars. But one more thing that I did before testing this at the nearby lake is to fasten a strong emergency line to the insulation board so that I could pull the raft out of the water should anything go totally wrong. Turning hard right and then going forward against the wind.
Hello guys, so here we are. That was the final episode of 2016 and I feel that's not much we can do about that. It's already in the evening hours of New Year's Eve here in Germany and I hope that you take this as a sign of my determination to work on every day of the year to make great content possible. And I also have to thank everyone who has helped me over the course of this year, either with Patreon donations or other kinds of donations, be it monetary or equipment, also people who spread the word or who just gave me positive feedback. A big thank you to all of you. This wouldn't be possible, this life wouldn't be possible without you guys. All I can do is to promise that there will be a lot of great content in the future as well. I have hundreds of ideas in my head that I want to implement. The only thing really holding me back at the moment is that I'm living in this tiny apartment here without daily access to a great workshop. So my big project for 2017 really is to find a workshop in Cologne or somewhere nearby in order to build bigger things and to work on more interesting projects. And if you're not by any chance from around here and have a great workshop to give to me, then the best thing that you can do to ensure the future of this channel is to check out patreon.com/tpai and become a Patreon supporter. Kick in as little as $1 a month and you can also cancel that at any time if you don't like my content anymore. You can also make a one-time donation by checking out the video description. There are PayPal links and stuff like that. Or otherwise you can just contact me under inventordonations@gmail.com. Now I just had to get this message across because, well, my future is still very uncertain. especially on a financial level. I still don't know what I will be able to afford in a year from now, for example, so renting a workshop is still a big step. Well, anyway, I hope that you liked this video and everything else that I made in 2016, and I sincerely wish every one of you a happy new year 2017.